Okay, Ellen, I'll kickstart the seminar now. Uh, Hello all. Thank you for joining today's seminar. My name is Vijay Gunti and I am an IoT consultant with AI Priory. And today we will talk about the Industry 4.0 adoption in the chemical industry and how existing data channels can be leveraged to obtain a connected chemical experience. The talk will be presented by Alan Jones, Chief Data Innovator and Founder Director with AI Priory. Alan has been a respected data scientist with over 30 years of data experience, having served as the CDO with Cranes. Along with him, we have Dr. Lloyd Colgrave, who is chemical advisor with Air Prairie. He has recently retired from Dow. He holds a PhD in chemical physics and a BS in chemistry. He has spent 29.5 years at Dow and about 21 years in manufacturing, almost all the time related to data generation, analysis, or plant problem solving. The talk would be kicked off by Alan, and then Lloyd will lead the second half of the talk. Finally, we will close out for question and answers and conclusion. With that, I would like to ask Alan to take over. Alan, over to you.
Okay, thank you very much. There will be the usual slight delay whilst we share screens. And as soon as you can see a screen, let me know. Is my screen visible? Okay, thank
Yes.
you. Okay, so VJ has kindly outlined the agenda for today, which is there. I will also now start talking about what I'm going to do. So the firstly is the usual plug about AI Priori. We're a data startup. We're 3 years old. We're based in the UK. Our focus areas are in ports, chemicals, energy, and other process industries. We have local delivery and management with our offshore development center. And when I say local, I mean local to the customer. We have representation in US, Mexico, Turkey, India, and the UK. So what I'm going to talk about is the data science in context in the enterprise, in the organization. Lloyd will take a more specific view of the chemical industry. So a lot of what I'm going to talk about is general enterprise. As VJ said, I am a senior. I have a lot of experience. I started out being statistician. I then became programmer. I've worked in many sectors, and finally worked for Cranes in Finland, setting up the data science practice. And as you can see, I have a penchant for old technology. That's my grandfather's IMIG C3 16mm movie camera. So a lot of you will be in existing organizations that probably have got a well-established routine for business intelligence. And now we're coming along to say you need to do something different. And what I'm trying to explain to people is the difference between BI and the data science. And normally there's four areas of difference. One is focus, in that BI tends to report on measures and looks at trends. It tends to do things once a month, once a year, once a quarter, and is comparative. How does this figure compare to last year's version of this figure? Data science is much more about, okay, we have a trend, what might be driving that trend, looking for patterns, correlations, defining models going forward. And it's much more experimental, exploratory, and more research based than perhaps BI is. And then the data sources, data science will use anything it can possibly get its hands on, whilst internally it tends to be more internal sources, the finance department, the HR, marketing, whilst data science tends to try and combine data from multiple sources into one area. And then quality is probably not the right word here, but it's BI tends to have one version of the truth. it goes for a definitive answer. The number is 27 and that's the end of it. Data science is a little bit more imprecise. That's a contradiction in terms between data science and precision, but it looks for things that are good enough. And that's probably fine when you're talking to the marketing director because he's quite happy at 90%. Your engineering department might need 95 or 99%. So there is a difference in quality. Having said that, often when you see comparative reports and you then go and check the figure from last year, somehow it's changed, even though the finance has changed. And another quite interesting difference between BI and AI data landscape is in BI, you tend to pick two or three different, you pick Click or you pick Tableau or you pick JEDOX and you pick a data source and that's it. Where AI comes in is that there is a huge number of options that you can take. This shows how since in the last 8 years it's ballooned exponentially in terms of what's available. It's fragmented, it's specialized. This adds to more complexity when you're trying to explain to somebody why you should be doing something with this particular tool in this type of area. And the specialisms which are coming out is that data scientists who are good at computer vision are probably not going to be good at time series. Your social analysts will probably need special skills which your speech people won't. So this is all about fragmentation and a huge choice, which again is something which large corporations with well-established processes and well-established procedures have a difficulty with. And we spend a lot of our time getting over the first hurdle of why we should be doing something with this particular piece of software. And this is all about software. However, and this highlights the differences between what I think are statistics and what are data engineering and data science. Are all those, this is usually the audience participation piece when I have an audience, but I shall have to do it. I'll have to pretend that you're all jumping up and down and answering the question of, are all these the same? Statistically, they are. They all have the same mean, the same correlation, the same linear regression, and the same coefficient of determination. This was created in the 1970s by a statistician called Anscombe, and he was trying to get away from the impression that once you've run the statistics, that's the end of it. The statistics are a definitive view. If you then start mapping the data, you start visualizing the data, you start looking at the data in more detail, you see a lot more detail. You can see the outliers, particularly in D, there's an outlier which is skewing the whole thing. If you're a sales manager, which would you rather have your sales in A or B? It's really important to actually spend some time looking at the data rather than just taking the KPI measure is 6, great. However, in defense, statistics do still matter. Empirical laws still apply. Just because you've got trillion records doesn't mean that they are the best trillion records you've ever got. It might be that you're missing another trillion which you don't know about. Equally, your 400 could be a really good fit for the problem that you're trying to achieve. You have to understand things like sample sizes. What's a valid sample size? Do I have to use a trillion records or can I just cut that down to 20,000? Also have to understand the cone of confidence. I don't like using the word error, but you have to understand that there is an error rate in your calculation. And we've all been exposed to this over the last year when we've seen projections of COVID-19 infection rates. And of course, everybody concentrates on the big figure. The highest possible number is 100,000. The fact that we're only doing 30,000 is minor minor. It looks better, but is it really? And then you have to look at probability. What's the probability of something happening? Given that you've got some error rates and given that you've got past events, what's the probability of something happening? And again, all of these need to be involved. Again, ask, is it a big number? You know, we've said, is 100,000, is that a big number in the UK when it, in a population of 60 million? Just keep in mind that just because someone says a big number, you have to actually look at what is behind that number. And again, I can remember being sat in a meeting a while ago where the company said, we print 7 million pages of A4 every year. And whilst they were arguing about where the number came from, we got a piece of paper and worked out that given the size of the company, given the number of days in a year, everybody was printing about a page a day. Is that then a big number? Perhaps it detracts from the fact that someone's trying to save the company money, but it's, you know, keep in mind, always be inquisitive about the number and always ask, you know, is it a big number and why is the number like it? So elements for the things that you need to organize to get your data channels working and being useful. And basically 4 things: data, people, culture, tools. Standard approach to anything is, you know, supply, demand, and who's going to do it. On the data side, the most difficult thing that I've always found is the organizational, getting over the privacy, getting over the security issues, understanding that there is a subtle difference between legal and ethics. We've all heard that, you know, Google famous, was it Facebook that said, you know, do no evil? But is that evil legal or is that legal ethical? You will get this over and over again about you can't do that because, or you can only have half the data you need because of privacy issues or security issues. The fact that people don't know what sat on people's laptops, sat on servers, what data is being extracted from ERP systems is a minor issue compared to somebody standing up and saying, you can't do this because. And you have to, unfortunately, go through the organization to actually understand where they're coming from and overcome it. That, to me, is the hardest part. And we've got this ownership of data. I can remember spending a long time in one company working out who owned the customer data. Was it finance? Was it the divisional? Each thought the other owned it. And then when you want access, you then have to go and talk to somebody else because they think it's part of their role, usually in IT, and they usually take the gatekeeper approach of you can't come in unless your name's on the list. Once you've done all the organizational things, you can move on to the technical things. You know, what data have you got where? Cataloging. What's available? How do I get access? Do I get a table with meaningful headings, or do I get a table that's just, you know, table 5, column 1? How does the metadata work? Is there anybody who knows the content of the data? Is that documented anywhere? And usually that's in the head of about 10 people who are all very busy because it's all they know, and everybody's asking them, what does this column mean? How does this work? Where is it in the data warehouse? Is it in the data lake? Why aren't we collecting it? How long did we collect it for? So the technical issues, again, really still go back to organizational. If all of that fails and you can't get any data or you can't get enough data, use somebody else's. This is open data, freely available data sets. We did a project with an HR department that wouldn't give us the data because of privacy issues, and but they wanted to know about attrition rates. Who was likely to leave in the next 6 months because there was a merger and acquisition coming up and they didn't want to lose I wanted to see who might be vulnerable. So to prove that we needed the data, we got some data. We got an open source data set about attributions and features and things which they thought we shouldn't have, like, you know, age and sex and where they lived and how far their commute was. And we did study using third-party data. And at that point, the HR department understood why we were needing what we were asking for. And luckily, we then got most of what we needed, as some of it still wasn't being stored in the HR systems. And if that fails, then you can create some. There are lots of libraries and websites and algorithms that will create synthetic data for you. And this is very useful when you're trying to prove a concept to somebody. So again, don't be downhearted if you're hitting a brick wall. There's always a way through. Tools. Yeah, okay, Excel. I have a very strong view about the use of Excel, and because it's the only thing that's available, everybody uses it to do everything with. And it's an absolute nightmare. I've forgotten the amount of times I've been given 27 Excel spreadsheets and told them, that's what we want, make it work. And then you're constantly looking, where do you get this data from? Do you realize you've missorted these columns and it's all gone out of sync? Having said that, if that's the only thing that's available to you, use it, but also investigate what else the company has lurking. Everybody will have bought perhaps some Tableau licenses. Everybody might have bought a subscription to SAS. Look what's available. Again, if all else fails, use open source. Yes, IT will get upset with you because it's insecure. You don't know, it's unknown software. But on the plus side, it's free. And what I often found was I would use something for 3 months, throw it away, get something better. And that's the beauty of open source, is it's compostable. You don't have to use it forever. And if you find something that works for one project, use it. If it doesn't work for the next project, find something else. There is a huge amount of available software out there. And the main aim is that it doesn't cost much, it just costs time. Which is basically now coming onto the people of, to do this properly, you will need somebody who knows the business. Usually they're called domain experts. Somebody who understands the chemical plant, somebody who understands how the business processes work, somebody who can help you. You then need, let's call them skilled intermediaries. These are people that can operate the tools efficiently. And you can use internal or external, or they might be the same person. You might have a domain expert with skills. Really important here is that you have to have some level of curation. You have to, one of the projects which we're involved in is that we had the domain expert with skills, and he created a project. We were then brought in to turn that project into production. And it was clear that he'd been left to do whatever he wanted. So he'd managed to create his own company structure using Excel in this case, which was a nightmare because it didn't match the current company structure and it wasn't updated and it was 3 months out of date. So again, curation is really important of somebody, and this can be somebody from IT, it can be somebody from the business that knows a little bit more about the data and infrastructure and IT. And then the next really important thing is asking the right questions. What problem are we trying to solve? If I gave you the answer now, what would you do? How would you go about putting that into action? That's very, very critical. And then finally, culture. I can only comment on my background. I don't know your company, but you have to work out, you have to prove something first and show this particular person to get traction later on. There's the I know syndrome. You go into a meeting, you spent hours doing your wonderful presentation, you find that this is a critical thing, and somebody at the back goes, well, I knew that, but did you tell anybody else? No. Did you keep it to yourself? Yes. The other thing is that failure is inevitable. You will hit brick walls. You won't find stuff. The data won't be good enough. You can't find anything. And then focus on outcomes and actions, which is going back to asking the right questions. And the graphic is the standard one of that, you know, enterprise IT is seen as the laggard here. They are the department that stops you from doing things. So get them on side as soon as possible. Finally, one simple user case about pricing. This was for a service company, and they reorganized their sales teams, and then they realized that the information and the data design hadn't matched the new organization. And they found that quotations were taking too long, customer specific information wasn't being taken into account. It was held in multiple places. I think in this case it was 2 systems and 2 or 3 reports that had to be run together to find what needed to be doing. And then technical knowledge was needed in too many occasions. So new people in new roles were reaching a point where I don't know how to quote for this. So what we did was we automated a lot of it, in that we automated priorities based on customer behavior, customer history. Now, this customer is more likely to buy this product, so they go to priority 1. The price, customer, machine variation was taken into account. Was this is what they've paid in the past, this is what other customers have paid, and then you can correlate between the two. And the order history was then used, as I said, to prioritize the outcomes. And because this had to be, we couldn't amend. You can't amend SAP. You know, it's just too much. We created our own web app that was then in a user interface that then allowed easy access to the quotation system or the parts availability system. But this was in its own user interface, tailored to each individual user. So they came in the morning and their task list was these particular cranes needed to be quoted against. And the main benefit was the increase in throughput in the quotation creation, in that became virtually 50% increase by just bringing information together and prioritizing it. Okay, so thank you for listening. Lloyd, it's now your turn, so I'll stop screen sharing and take it from there. Thank you. Are you there, Lloyd?
Oh, I'm sorry, I got muted. I did not realize that. Good morning, good afternoon, good evening, everybody. And while I get this set up, I see Livia lurking in the background. Hello, Livia, how you doing? She's one of my new friends. So,
hey, Lloyd.
Let's see where we're at. My job today is to talk to you about the chemical industry and give you just a few brief examples of that might spark your interest if you are coming from a chemical enterprise, into how a priority might be able to help you. So as Vijay already said, I'm a chemical physicist. I'm not a data scientist. Very clearly, I found someone like Alan very early on in my career at Dow to help me do data science, because I am not a data scientist. I did direct the application of AI and the chemical process data interrogation since 2004. We called it chemometrics back then. And before that, I was trying to convince everybody that the data actually was correct and trying to tell them something. And I was curious why nobody was paying attention to it. And we can explain that a little bit with one of my pictures here soon. I'm working with AI Priori and other folks like them to advise them how to communicate effectively with the chemical industry. And I have several clients who are asking me to help them translate what the capabilities of a company like AI Priori are into their shop. I'm very adept at helping teams pick the right problems for AI and to suggest to both parties alternative approaches if that's not working out. So real quick, in the chemical enterprise, at least when I got into the manufacturing side of my company back in the late 90s, we were really into what happened and why did it happen. And because process data historians, Aspen, OSI, Pi, you name it, ABB, all these different capabilities, we're very good at trying to figure out what happened, very good at figuring out why it happened, and in many cases, sort of what is happening now. That was traditional data usage in the chemical industry. By the way, that is a gross oversimplification of a very complex process. What I got involved in is, well, if you're really good at finding out what happened and why it happened, why don't you try to either predict what's coming in the future or know when something's starting to build in your process, get ahead of that and avoid all the problems that everybody was getting, patted on the back for solving after the fact. And honestly, that's a hard conversation in a company that is in love with the reporting analysis and monitoring of their plants. What I wanted to do was get into prediction and ultimately simulation. So what might happen in the future or what is likely to happen. And the further you get up this graphic here, the greater competitive advantage I believe you have. That's my personal opinion. And the further you get up into this, more and more and more you get into the realm of what AI can do for the chemical industry versus what we're doing now. But I am a big proponent of real-time analytics. So the monitoring, I've had a big hand in my company of changing how they monitor their data. And part of that is how do you view the data, but also looking at some others. So I'm going to give you some very simple examples as we move forward in this conversation. I'm not going to spend a lot of time. But just for everybody on the phone, whether you provide analytic services to companies or you're trying to figure out how to get analytic services delivered to you, Alan actually touched on this in a beautiful way. Alan, I loved what you said this morning. But I'd like to break down the whole analytic discussion into three areas: real-time analytics, statistics, and artificial intelligence. Or by the way, back in my day, folks, we called it chemometrics. We'd been using, quote, AI for more than a decade before the term even started being used. And it's just multivariate statistics as applied to massive data sets. Now, real-time analytics, if you've ever seen a GPI board in a chemical plant operation, you've got all these lines running across the screen, everybody's staring at these lines, and the minute one or two of those lines converge when they're not supposed to, everybody jumps up and goes, oh my goodness, we've got a problem. And so that's fine, but I was looking for tools that would help the operators do a better job of understanding what's happening, what's coming, and I also wanted systems that were evaluating broadly all the data so that the individuals didn't have to do that. And so that is real-time analytics. And that is a space, by the way, that A Priori can help you. And there are also lots of other different options out there. Statistics is, in my mind, to clarify what is uncertain in your data. And so as Alan eloquently illustrated in his conversation with you, statistics is something that is still necessary, but it is a tool to drive the decision-making process and should not be something that is feared because you feel like you have to walk into that room to make a decision. It should underpin anything you do on the left or the right. Now, artificial intelligence in the chemical industry, and why I call it chemometrics, it's a combination of statistics, mathematics, and chemical engineering and chemical science. AI should never be used to remind you that you're violating the first or second law of thermodynamics, for example. If in your chemical process you don't understand the fundamentals, no amount of data engineering in the world is going to keep that plant from going offline or hurting somebody. So let's be real. And there are certain industries where you can go in and do analytics of very loosey-goosey data sets or very broad data sets. The insurance industry is one classic example, and this is how we know that 18-year-olds are a bigger risk, male 18-year-olds are a bigger risk than anybody else in driving. But in the chemical industry, you need to put the domain experts, as Alan said, with the data scientists and get that discussion right. Because what AI will do is tell you things about your process that you might not have been aware of. And then the domain experts need to be able to tie that signal to something physical happening in the plant and know what they need to go do. By the way, I can spend an hour with you on why AI will not be running plants in the next 5 years, but that's a different conversation.
Yeah, Lloyd, Vijay here, Lloyd. The screen share stopped. Can you reshare it?
Oh, I'm sorry. Yes, hang on a minute. I don't know why it did that. Screen share. So you do not see the last picture.
Yes.
Oh, I'm sorry. Okay,
Yes.
so very quickly, I'm not going to belabor the point, but let's see. This is what I was showing everybody. Okay, so real-time analytics, statistics, and AI. Now, so I just made this slide up and I just shared it with my friends at AI Priority. I'm going to be talking a lot about this particular slide in a conference next week in Austin. But I don't want you to look at each of the details of this. I want you to recognize that there are different locations of data in a chemical enterprise. The business has data. The plants, of course, have their plant data historians. The labs and the quality analysis and the analyzers and all the things may or may not be within that database. They may be separate. And of course, you've got a huge library of knowledge and information that is now stored behind a vault that is so protected from outside incursion that even the people in the company can't get at it very easily. And in my mind, that's the data opportunity for a chemical plant. In my experience, this started about 8 years ago, I had lots of companies coming to me and say they could take care of my data problem. And they wondered, why was my industry so hesitant or so reticent or so frustratingly difficult to get in the door to? And that's because, well, if you look at the asset framework we have, it's kind of a hot mess, but it's there. And then data analytics means a lot of different things to a lot of different people. And oh, by the way, there are different users in your chemical enterprise. You have transactional users, you have tactical users, and you have strategic users. And not all these people have the same ability to consume data. They do not have the same ability to manipulate data. And it's just a gamish. And nobody in 2012 or 2015 is going to walk in with their data, their suite of data tools and replace all of this, because there's no money in it for any chemical enterprise to replace SAP or replace the processes that are currently running their plants or rewiring their plants. Or, by the way, there's not a lot of money in adding more sensors. So where AI fits in the chemical industry, I've got a circle around it. AI fits where you need to take the existing architecture and framework and data and try to make better sense of it. AI is used to help you understand the things that were not engineered into your process and the effects that were not engineered into your process, and help you understand how you need to respond to those effects. In the chemical industry, variation in raw material, variation in temperature, some unknown failure within the process that was not anticipated in the process control or process engineering, all of that can be managed through the artful use of artificial intelligence on the data sets. You can get to machine learning. I'm not sure that deep learning is going to work too well in the chemical industry, because unfortunately the data sets that we use to make decisions, even in an AI framework, are not complete enough. I can go into a 20-minute discussion as to why it's okay to be wrong about whether you need Clorox wipes or toilet paper during a pandemic. The reason we didn't predict that in our supply chain was because we had no data to experience that, but it's inconvenient. It's not going to kill anybody. Well, in the chemical industry, if we don't have the right data sets to make the decisions that we need to make, we'll end up hurting the environment, the neighborhood, or individuals in the plant, or our customers, and we don't want to do that. So therefore, AI does have a place in the world, but it is not the key answer to everything. I wanted to use this slide to remind everybody that data visualization actually can be very simple. If you haven't in your chemical process or in your plant taken very simple looks at your data first, you really don't know what's there. And honestly, it's the place to start, because I'm going to tell you, and this is where AI priority can help. I'm going to tell you, you need to understand which problem you want to go after, not which tool you need to use. It's not a question of finding it. It's like a hammer and a nail. Once you have a hammer, everything looks like a nail. No, there's different kinds of tools within the AI framework that AI priority, for example, can bring to you. But also you need to understand what you want first, and then go find the right tool and get the right people to help you do that. In this particular case, by the way, all those massive number of data points above the upper control limit, that was how the plant normally ran their plant. And you say, well, Lloyd, how is that possible? Well, honestly, when you've got 2,000 or 3,000 data streams coming into your plant and nobody can look at all those data streams, this kind of situation can happen. Well, the minute you set something up, and AI priority, by the way, in a chemical plant can easily do this for you. The minute you set something up, all of a sudden people are paying attention to something they did not specifically go out and look at. And they very easily became aware that the plant was running out of control a lot on this particular axis. And you can tell very clearly exactly where some people started to work on it. Well, there's still a few incursions because people were getting sort of sloppy about it. Well, the funny thing is in this particular picture, other people also started looking at the data who had not seen it before. And as you can tell, after a couple of days or maybe a week or so of working through this, that thing got back in control. And by the way, anytime it pops up again above the control limit, if the plant doesn't do something about it, someone will call them. And that was a very annoying revelation, but it paid off handsomely for the company. And that's a very simple example. So I'm going to go to a more complex example now. The reference at the bottom of the slide is a paper that my colleague Leo and I wrote about in 2007. It's something we did much earlier. It's a batch processes, and this is how we applied AI to a batch process. Our product had 9 different quality measures. We shipped it off to a customer, and the customer came back and said, this failed in our application. And the vice president called me up one day and said, Lloyd, this failed in the application, but it passed all our quality tests. Why? And so actually, back to Alan's point, at the time, my jump license had expired. I needed a quick tool, so I pulled up my Excel and I plotted X versus Y across a bunch of different things. And what I was looking for was correlations, and I wanted to see where that dot, that one lot of material in the production process showed up in that map. And here's what I saw. So you see a galaxy of points, and I've simplified the picture a lot in this case. You see a galaxy of points there, which correlates to 2 things that should correlate within the process. Think of it in this case, let's just say, the bigger the molecule, the more viscous it's going to be, okay? So molecule size and viscosity should correlate. Well, the product we sent to our customer was sitting off axis, and that's really cool. We just violated a law of kinetics and chemistry to produce something. And so honestly, it's not possible to produce that data point, the one you see that's circled on the right. And oh, by the way, I cleaned this all up because there were lots of data points off in the upper left or lower right of that graph. Well, so, I noticed this on a stupid presentation I did in Excel. I called up Leo and said, hey, Leo, I need for us to look at the multi-factor space that is this product, and then try to figure out how we can keep from making this mistake with this customer and any of our customers again. So input chemometrics or artificial intelligence to this batch process. What we did was we created a model, and that model started looking at all the different batches we had produced up to that point. And then we started to look for violations of a core area of that model. We actually parameterized a space that looks like an American football. It's what we call oblate spheroid, but it's an actual 3-dimensional object. But in this case, it's 9 dimensions. And this is what AI can do for you in this particular case. It's a 9-dimension graph, and you're saying, but Lloyd, you're only showing me 3. Well, that's true, because I can't draw you a picture in 9 dimensions. But all the red lines there that look like they should be conforming because they're close in around that particular bundle of green data, they're non-conforming in one of the other axes. And what AI was able to do was tell us which axes of the 9 measures we were doing it was non-conforming in, and oh, by the way, by how much. And so even though on 3 axes you could say all of those are correlating and those are probably perfectly good pieces of data, the reality is that no, they weren't. And we use this data not only to keep our customers from being insulted, we also use this data to improve the process, because we were showing the plant and showing the business something they had never seen before in the 40 prior years they'd manufactured product. And we did have to go in and use fundamentals of chemistry and engineering to figure out why the product was doing what it was doing. And we were quite interested in what we found out. So this is one application of how do you use your data more than what you're currently used to gain insights into your process. And again, there is a reference to this if you want to read more about that particular picture. So, all right. I was a quality manager at Dow for many years as I was starting to build the analytics capability within Dow. And one of the things I learned was that you could use AI, for example, to do raw material qualification in your plants, because in the chemical industry, if your purchasing calls you up and says, hey guys, we got a better price on this raw material, what do? Well, I know if you're in the chemical industry, you have a process for trying to figure out whether that product is going to work in your plant properly and it's going to produce what your customers expect it to produce. And so what do? Well, you got to slow down production at some point. You've got to do a little bit of vetting, typically not nearly enough on the raw material from samples they send you. Then at some point you have to have the nerve to go in and try to figure out whether that raw material is going to damage your plant or work right. And at some point you cross your fingers, you pump a bunch of that stuff into your process and you start measuring and looking at the product as it comes out the other end and hope to goodness that everything is going to go okay. Well, so in that sort of paradigm, you can also do it another way. And that way is to use principal component analysis, which is what AI is in its base form, to take a look at the raw material variables of the two different suppliers and see how they differ. And you can go back to the supplier with this information and ask them to make some adjustments. Maybe they can't. Maybe it's still within the parameters that your process can consume because you understand what your process is designed for. You can make a multivariate quality model with this based on the normal product data and the old material information from the old material and see what kind of response your process will give you. You can conduct a plant trial virtually with these models to figure out if the raw material is going to work. And if you don't see any multivariate quality control alarms, then you can actually approve this new raw material supplier without the normal trial and error process of raw material verification. I know from a quality perspective in certain plants, this is a really dicey problem. And so having the data in advance and doing the proper data debridement and getting the right experts to look at it initially can give you a good example of whether or not you're going to see any problems within that plant. Now, here's my favorite one. We've used AI hundreds of times when we get a phone call from our plant saying, we've got a strange problem, it's periodic, we think we've solved it, it goes away, and then it comes back. So anybody on the line who works for a chemical company, if you don't have this problem and you're a major chemical manufacturer and supplier, I think you haven't talked to your operators or engineers enough, but I could be wrong. I think it's probably the most common problem in the chemical industry. And oh, by the way, there have been books written about this problem. How do you solve the problem once and for all that keeps coming back? In some cases, by the way, plants believe that that problem is just part of the engineering of the process and they should just accept it. Maybe you need to clean out that filter or that raffinator or that separation system every 2 to 3 weeks because that's just how you've done it for the last 30 or 40 years. Well, a priori can easily come in and look at your data sets, work with your experts to figure out what signals you have been ignoring or what signals you didn't notice, or the correlation, the data in between. What are those correlated or anti-correlated signals that might give you a clue as to what you have failed to consider within how you run your process? And then once you can define the parameters you need to look at, you can either draw them back to contextualize them back to the fundamentals of the process, or bring new measures and monitors in just from the data you already have. I'm not saying putting new instruments in necessarily or new data streams, but just taking a look at the data you have and letting it tell you when it starts to see a problem. This is a huge winner for processes that have this mystery problems. And if you do not have this capability within your company, it's perfectly viable to bring in companies like AI Priori to help you do this. And this is a real money winner for you. Now, I'm going to use this picture very briefly. I'm running out of time. I know AI can ease the revelation in complex data. This graphic was just a generic picture of something very important to a group of people. It would take one engineer about 5 or 6 hours to generate this on a Friday afternoon every week. That was not a good use of her time, and she had better things to do. And AI and the tools that ball up into AI can help you make those kind of decisions much, much faster. And finally, back to simple analytics. I'm going to show you this slide. This has been shown numerous times around the globe. If I take a look at data, all your data in your plant, using any sort of type of dashboard tool, and I set some basic parameters around your data and start looking at it, I'm going to find out that my plant more often than not is running in violation of those parameters that were set when the plant was engineered and when the plant was designed and when the plant was built. But once you bring this to people and let them see this, you can then go in and take a look at each one of those parameters and start to get them back into control. And this is what I've got in front of you is literally a 2-week process. It wasn't that painful. And then everybody can see how the process is running and move forward on that. And this, of course, is something that is also within the wheelhouse of AI Priori. So these are just some examples of various ways that artificial intelligence or the tools that roll up into the bigger concept of artificial intelligence can be used to help aid you in the chemical industry. And with that, VJ, I think I'm going to hand the mic back to you.
Thanks, Lloyd. So now I open the floor for questions. So if anyone have questions, you can ask for Lloyd and Ellen. Any questions from the people? You can unmute yourself and ask the question. Lloyd, I have a question from the group. So let me ask you that question. So you mentioned helping people pick the right projects for AI. Can you share what you look for in a good problem for AI in the chemical industry?
Okay, so honestly, the first thing I would like to know is how much is that problem costing me? So I'm going to look for high dollar injury to my plant or potential safety violations within the process. Typically, if I could walk into anybody's operations room and sit down with an operator and talk to them for 5 minutes, I would find a problem in the plant that is recurring. It is annoying. The alarms perhaps are even that particular issue. The operators don't know what to do with it, so they keep pushing the button to turn it off. And so I get very curious. I used to get very curious about those things. We'd usually go back and find out by looking at the broader data set in a chemometric or AI viewpoint. We'd start to find signals within that data that would tell us that there was a problem. Usually it would culminate in something big later on down the line. So we would start to figure those out and we get rid of those types of alarms. Those are the kind of problems that I'm interested in working on. However, it's very handy, as I showed you with that one batch process of monitoring your quality data coming out of your labs and helping you avoid embarrassing incidents with your customers as well. So it's really what's it costing you, what's the money, and do you have a data set that you're willing to let people play with to figure out what the problem might be.
Thanks, Lloyd. Alan, this question is for you. So you mentioned about synthetic data. So can you explain more on that?
Okay. Yeah, synthetic data is obviously data that you create in a particular way to solve one of your problems. And usually they fall into a number of areas like the data doesn't exist because it just doesn't exist because no one's recording it, or it could be it doesn't exist because it's going to be a new sensor or a new machine that's going to generate this type of data. It could be because it's data of a sensitive nature that you need to generate 50 imaginary people from Ohio, for example. But you can also use it to test your models by introducing outliers to existing data sets, or produce an ideal data set that fits your model perfectly, and then see how reality deviates from that. And in more advanced situations, you can get it so that it can produce accurate and completely labeled data, which if you use real data will be too expensive or too time consuming to produce. And there are a number of algorithms that you can use. There are a number of libraries that you can use to generate the data, or you can just go ahead and just do it yourself. There are also websites that you can buy data from, but a lot of the generators also use, you can give it a little bit of data and it will generate more data based on the characteristics of the data you've given it. So for testing purposes, you can use it as well. You're on mute, VJ.
Thanks, Alan, for that. Yeah. So any questions before we close this seminar for today? So we have another 5 more minutes. You can unmute yourself and ask the questions. Okay, so Alan and Lloyd, right? So thank you for your presentation today. So we are closing this seminar now. So thank you all for joining this seminar.
All right,
Thank you
y'all have a
very
safe
much.
day.
Thank you all.
Bye-bye all.
Bye bye all.